All right, so what we're going to be doing for the rest of this lesson is solving exponential equations. So we are going to be solving things with x in the exponent. So take a look at number 1. We have 3 to the 2x minus 1 equals 3 to the x plus 2. And notice these bases are the same. Okay, they're both 3's on the bottom. So what that means is we can kind of ignore them. They don't cancel out, but we can just kind of ignore those and say, look, if the bases are the same, that means the exponents have to be the same. So we're just going to take the exponents and set them equal to each other. And then we'll just finish solving this. So subtract x over, add the 1, and we get x equals 3. Okay, so since the bases were the same, we could assume that the exponents were going to be the same. Now, when we take a look at number 2, we want to know, can we solve it the same way? And the answer is no. Okay, because the bases are not the same. Okay, this is a 2 and an 8, so we can't say, oh, these are the same, so x must equal 3. That doesn't work. But can we modify this? Can we modify this equation so that it does work? And let me just rewrite this equation. 2 to the x equals 8 to the 3rd. Can we manipulate this so they do have the same base? So I want to show you this. I recognize that 8 is the same thing as 2 to the 3rd power. Okay, so I am replacing this 8 with 2 to the 3rd. Okay, now that other third on the outside, I didn't do anything with that. So now what I have is 2 to the x equals, and these 3's, I can multiply them. That's 2 to the 9th. Now I have the same base, so I can just kind of ignore those and say, look, since the bases are the same, the exponents have to be the same, so x equals 9. We call this the 1-to-1 property. Okay, if your bases are the same, okay, 1-to-1, that means your exponents have to be the same. They're 1-to-1 as well. So what we're going to do is we're going to just practice with that. We're just going to manipulate some of our problems so we can use that 1-to-1 property to solve this. So check out number 4. We have a base of 9 and a base of 3. So we want to get them so they have the same base. You usually have to work with the bigger number, okay? So there's not really much we can do to change a 3, so we'll leave that alone. But the 9, let's leave this alone. 9 is the same thing as 3 squared. Okay, so we can rewrite this. The right-hand side is still going to be 3 to the 6x. And then on this side, we're going to multiply this 2 by both of those things. So this is 3 to the 4x minus 2. And now we can use the 1-to-1 property. The bases are the same, so we can just kind of ignore those. That means our exponents have to be the same. So 4x minus 2 equals 6x. And then I'm just going to subtract 4x from both sides and finish solving. So x equals -1. We can do the same thing even if it's an inequality. Okay, don't let the inequality scare you. We have 2 to the 3x is greater than or equal to 4 to the x plus 2. We want to manipulate this so that they have the same base. So again, usually we have to work with the bigger number, so we're just going to leave this alone. And hopefully you see that you can rewrite 4 as 2 squared. So what that's going to give us is 2 to the 3x, that nothing's changed about that. And we're going to multiply that 2 by both those things. So we have 2 to the 2x plus 4. Now, since the bases are the same, we can assume the exponents are the same. So we have 3x is greater than or equal to 2x plus 4. And then we're just going to solve it and just leave the inequality as it is, so x is greater than or equal to 4. All right, so let's do one more of these. Okay, this one's a little bit different because it's got a fraction in it. Again, 3, there's not a whole lot we can do with the 3. I don't know what just happened there. For some reason, it just does not want to write a 3. Here we go. Now, hopefully you can see 1/9. That's the same thing as 3 to the -2, because remember, to get rid of negative exponents, we move them to the bottom. So 1/9 is the same as 3 to the -2. And now, since the bases are the same, we can assume that the exponents are the same, 1-to-1 property. And we'll just finish solving this. I'm going to add 1 to both sides and then divide by 2. We'll check out the other problems in the next video.